Hey everybody, we're back with more stimulation.
It's not stimulation. We went through this stat. It's simulation.
Oops, I forget.
Yeah, you do. Anyway, so what are we going to be dealing with today? First, we're going to go back and look at the auction problem from last time and check your work on that, see what you came up with. Then we're going to work on more building one trial simulation models. The truth is, the auction problem is not a very good example of a one trial simulation. We'll deal with that when we get there. We're going to look at a problem out of your textbook. It's problem 6.2, an auto lease versus purchase problem. And we're going to have to talk about time value of money to understand that. And then we're going to introduce a real estate problem that isn't in your textbook. And we'll probably get to the very beginning of actually replicating trials. So, here's where we left you last time. We said take the auction house problem, problem 2.2, and just put in two different distributions for the winning bid. So here it is. I said to put in a uniform distribution, uniform between 50,000 and 150,000. So all you had to do is use the RAND between function and make it RAND between 50,000 and 150,000. So every time you hit the F9 key, you get a different trial. They're pretty much making, oh, there's when they lost money. They're pretty much making money most of the time. There's not a loss. And if you remember from this problem from chapter 2, for anything above about $83,000, they will at least break even. So if it's uniform between 50,000 and 150,000, they should be making a profit about 70% of the time. So now we have a working single trial simulation model for that one. Normal distribution, I did it all in one big function instead of doing it separately. So let's take a look at the function. I put the random component right inside of the normal inverse. Remember, the normal inverse asks for the probability and the mean and the standard deviation. And in this case, I did hard code the mean and the standard deviation. For this particular problem, I thought that made sense. Maybe it doesn't. Maybe I should have put input somewhere in the sheet for the mean and the standard deviation. But this is the way I did it. Same thing. Sometimes they make a profit, sometimes they don't. Single trial simulation model. Now I have on the PowerPoint that this isn't actually a particularly good example of a single trial model, and it's partly because it's honestly a little bit too simple. Even with the if statements built into here, it wouldn't be that hard with a distribution of inputs to figure out a distribution of outputs. You could do what's called an analytical solution. You probably could solve this with some complicated, semi-complicated mathematics. We will still do the full simulation with it, but it's just got the one random input. It gets more interesting when different random inputs counteract with each other. So if you didn't get these right, you should stop the video now and go out, open up the problem, and do it to make sure you've got a sheet that works just like this. Because I'm not going to give you the solution sheet. When we get into doing a full modeling problem with that, you're not going to get my solution. So just so you can see it again on here, that's how you do it with the RAND between a uniform. And over here is how you do it with a normal distribution. So again, stop the video, go fix your own. Stat and I will wait for you.
We'll wait.
Okay, if you're back, let's move on to a brand new problem today. If you have your textbook, you can look on page 206 and read about this problem. It's a car purchase or lease. So you can purchase the car today for $43,240, or you can lease it for 24 months. And here's the relevant values. Down payment, the monthly payment for 24 months. There's a security deposit that you do pay up front, and you get it back at the end if you haven't trashed the car. And if you want to buy the car at the end of the lease, you've contracted that you have a set price of $29,732. In addition to these costs, there is a charge of 24 cents per mile for every mile you drive above 30,000 in the next 24 months. So purchase is just buy it. Lease is all of this. Now there's some assumptions. We're going to ignore taxes, license, maintenance. We're assuming it's the same whether you buy it or lease it. The market value of the car is reduced by the same 24 cents. And that doesn't change what you can buy it for. If you buy it at the end of the lease, you still pay this. But why does the market value matter? Well, what if you bought it? You choose this option, and at the end of the lease, you decide to sell it. We're going to have to look at what could you sell it for. So that's why that one matters. We do have some random components. The miles driven over the 24-month period are modeled by an exponential distribution with a mean of 25,000 miles. And we talked about doing exponential distributions in the last video. And we haven't talked about time value of money. We will in a second, but we have to have a relevant interest rate for time value of money. So we can model that rate by a normal distribution with a mean of 8.5% and a standard deviation of 1%.